learn about the atomic orbitals and electronic configuration, right? The arrangement of electrons around the nucleus can be explained by the quantum theory, right? The quantum theory has explained by a scientist called Planck. Quantum theory, Max Planck. He is a famous scientist who explained this well, right? Max Planck. Right. Now we are going to learn about this the quantum theory and how it works, right? The quantum theory tells you the how the electrons move in exact cells. That is a simple explanation for you, how the electrons move around the nucleus in exact, constant route or a sort of a path, right? When you are in a lower grade, you have learned how to draw an atom and how the electrons are moving in the relevant shells, right? I'll take an example. I hope you can remember about sodium. The atomic number of sodium is 11, okay? Whenever your teacher was asking you to write the electronic configuration of sodium, you used to write 2, 8 and 1. 10 plus 1, 11. So here, as an advanced level student, you are not going to write this anymore, okay? You have advanced level of representing this. In this part of lesson, I would like to drag your attention of writing the electronic configuration by using the quantum theory, right? So, as I told you, let me draw for sodium. I'll write sodium in the corner the way it has formed. This is 11, okay? Right. The atomic number is 11. Right. 2, 8, 1. Here is the atom of sodium. This is what you have drawn in your lower grades, right? Here you have represented electrons, and here also you have represented another set, right? And at last you have one electron in the outermost shell. You can mark it anywhere as you wish, right? But now today, after today onwards, you will understand and you will start to write it in a different way, right? Simply, I would like to call these as quantum shells. This is the first quantum shell, which is closer to the nucleus. It has the lowest energy level, right? This is the second quantum shell, and this is third, so on. You can write 4, 5, 6. But sodium, it has 3 quantum shells. That's why teacher drew only 3 quantum shells. My dear children, you have to remember, when you are drawing a quantum shell, there are sub shells too, right? As I have told you, in the first quantum shell you have the lowest energy level, right? Whenever it proceeds, it increases the energy levels, right? I told you in the first energy level we have a subshell called S, right? S subshell. And when it comes to the second energy level or the quantum shell, we say it is P. When it comes to third quantum shell, it is D. I am talking about the quantum shells, and these are the subshells of the quantum shells, right? Okay, this is the first quantum shell. Here's the second quantum shell, third, fourth. When it comes to fourth, we call it, it has SPDF. When it comes to the first energy level, it has only S. When it comes to the second energy level, it has two subshells called S and P. So when it comes to the third quantum shell, there are three subshells called SPD. And when it comes to the fourth quantum shell, it is SPD and F. Right? Right. Let me show you how to represent the first energy, what you call quantum shell, the subshell. First subshell, that is 1s. The second one, 2s, 2p. I told you the second quantum shell has s and p. So I have represented that. And the third quantum shell, as I told you, there are three subshells, that is 3s, 3p and 3d. And finally, according to your level, if you learn the advanced chemistry, you will learn further, but up to now, for your syllabus, you have up to the fourth shell, right? Normally, they won't ask from the fourth quantum shell, but it's good for you to remember them. Right, when it comes to fourth, it is 4s, 4p, 4d, and I hope you can remember this 4f. If I represent it in an order 4s, 4p, 4d and 4f, we can represent it in this manner, because I told you at the beginning, the first quantum shell has the least energy. So when it increases the energy too. Okay, right. And then the other part of this, I wanted to tell you the maximum number of electrons that S subshell contains. S subshell contains maximum number of 2 electrons, and P, it contains maximum number of 6 electrons. When it comes to D, it has 10 and here it's 14. Now you will see something here. In the first quantum shell, you will have 2 electrons. I will erase this, okay. Right. In the first quantum shell, the maximum number of electrons are 2. And the second, it is 8. And when it comes to third, it is 18. And last one, 32. See the connection? The first subshell has maximum number of 2 electrons. When it comes to the first quantum shell, it is maximum 2. Okay, fine. When it comes to the second quantum shell, the number is 8. Have you seen this? 2 and 6 makes 8. When it comes to third quantum shell, you see the change, 18. 6 plus 2, 8. 8 plus 10, 18. Right. Let's talk about the last one. The total is 32. Right? Okay. See whether you can understand this one. Right. Then we are going to talk about the orbitals. Now I told you in a nuclei there are quantum shells. In the quantum shells, electrons are moving and each quantum shell has subshells. At the same time, now I am going to tell you each subshell contains or represent orbitals. I hope you can hear the word very well. Orbitals. Right? I am going to clean the board. Right. As I told you, there are subshells called S, P, D, F and so on. Right? I am going to represent the shape, the figure of S orbital. Right. Whenever you are learning in the lower grades, children, you have learnt about the Cartesian plane. The Cartesian plane, let me draw it aside. Right, this axis is known as x and this is y. So you can join these and you can make a square, you can draw a circle, whatever the diagram that you want to represent, you can draw it on the Cartesian plane. But whenever you are going to touch it, you can't touch this. As it is, we call it 2D, right? But when it comes to this subshells and all orbitals, we can touch them as they are 3D. Now you see the pen, we can touch them. You can see another pen, a marker pen, that also can be touched. There's a keyboard, you can touch them. Why? Because they are 3D. So in this case, we say they are 2D, but here you are drawing 3D, right? So therefore, there are to become a 3D object, there are 3 axes. Here you see there are 2 axes. That's why we can't touch them. Because of 3 axes, we can touch the object, right? See how it works. This is x-axis, as you know. This is the y-axis and this is z-axis. We call this shape spherical in shape, sphere, because of that, right? Then this is the size of, this is the rough size of 1s orbital. 1s. If I am going to draw this, I told you it increases. So if I am going to draw the 2s, what will happen? I have to draw such a larger orbital, yes, spherical in shape than this. So you see this is larger than this. If I represent 1s like this, you are going to draw, you are going to point out, you are going to show this one as 2s. Then you ultimately you will know 1s, 2s, 3s, it will enlarge their sizes. Okay, right. This is the figure, this is the shape of s orbital. S orbital. Yes, now I told you we have S, P, D and F. Okay, now we are going to learn about P orbitals. We call the shape of P orbital is dumbbell in shape. Have you heard about dumbbell in shape? Yes. That also has contains 3 axes. Let me draw it. Sorry. Right. X-axis, Z-axis, Y-axis. Why I am drawing 3 axes like this, planes like this? Because I told you the maximum number of electrons are 6, so it will break. We are going to pair it 2 by 2. Right. Now we are done with it, right? This is called Px because it's parallel to x-axis. This is called Py as it is parallel to y-axis. This is called Pz as it is parallel to z-axis. We call this shape dumbbell in shape, spherical in shape, dumbbell in shape. If you want to learn more, you have to learn advanced chemistry. Then it is interesting. You will learn very well. I know you all are clever. And these are the things that you are going to learn for your level. Okay. Then we are going to talk about the electronic configuration. I'm going to clean this. Electronic configuration. Yes, that is our subtopic, electronic configuration. Right, at the beginning of the lesson I wrote the electronic configuration of sodium 281. That is the normal way, that was the way that you wrote in the lower grades. But now you are not going to write like that. From today onwards you are using this methods to represent the atomic number. Right, let's go to sodium once again, as we have come across with it. Right, okay, sodium 11, atomic number is 11. This, for your knowledge, for your sake, I am representing this to make you understand, but hereafter I am not going to write this. Right, I told you the first orbital is, first subshell is S, right? So first 1s, 2s, 2p, right, this is the first quantum shell, first subshell. Second quantum shell, two subshells are there, right? This is the first quantum shell. There is a single subshell. In the second quantum shell, you have two subshells called S and P. Right, when it comes to third quantum shell, we start with 3s, 3p and 3d. Okay, this is called third quantum shell. We are not going to write forward because we are going to stop from there. And now you see whether you can understand that I pointed out the calculations in the previous part of the lesson. 1, okay, here this 1 is these two electrons are filled in the subshell of the first quantum shell. Now when it comes to 8, what will happen? The maximum number of electrons is 2, I pointed out. Then P can hold 6. What will happen? This is parallel to this one, 2 plus 6, 8, okay, right? Then when it comes to S, 3s, because S can hold maximum number of 2 electrons, right? That's this is an example. We will take oxygen. What is the atomic number of oxygen? Atomic number of oxygen is 6. Right. Let's go to that oxygen 6. How do you write it? Let's write from the beginning. Yes, 2, 4. That's how you have written in the earlier days. But today you are not going to write like this. You will start like this. 1s, 2s, 2 to 4, 2p. Okay, see the balance now? Here this is represented by this part 4, then the remaining is 2. Right? Let me take something else. Let me take magnesium. 12. Atomic number is 12. Let's break this. 2, 8, 10, 2. Okay. Start to write. 1 is 2, 2 is 2, 2p 6, 6, 8, 10. So we have another 2. 3 is 2. But my dear children, there are different places whenever you write the electronic configuration. Especially you will face this when you are writing for the transition elements. Right? Transition elements you will learn in the grade 13, the 13th class. But for the moment, I'll take calcium. See calcium, it has the atomic number 20. Okay, let's break. 2, 8, 8, 2. We plan the electronic configuration, the filling will be happening like this. 1 is 2, 2 is 2, 2p 6, then 3 is 2, 3p, see 2, This is 2, right? Three S 2. See 8, 10 here, 6, 3D. Now what? Here 10, 18 and 2. But as we have we think it will be filling like this. No. Now you have, remember, we have learned the Pauli exclusion theory, the way of filling electrons, right? Remember, recall your memory. Right. This is for your knowledge, right? Filling of electron happens in this way according to Pauli's exclusion theory. See, 1s, 2s, 3s, 2p. Hope you can remember this Pauli exclusion theory. According to that, this won't happen. Though the calcium has to be filled, this last 2 subshells, it doesn't work like that. It jumps in this manner. 2s2, 2p6, 3s2, 3p6, 4s2. 3d is remaining just. There are people like that. They want to get the chance, but some other person may come and get the other one's opportunity or chance or whatever. This is like that. So I'm going to clean that because this is not to keep it in your mind. You need this part. What we plan, what we think is the filling of electron will be happening like this for calcium. No, not that. Instead of filling the 3D shell, it fills to 4s. Right? Okay. We have come to the end of the lesson today. That is how to draw the filling of electrons. See, you will catch up this easily because you all are clever students. Let's take sodium once again. Do you like to have sodium or something else? Right, let's write 1s2, 2s2, 2p6, then 3s, 6, 8, 10, 11, 3s1. Right? First of all, I am going to represent for 1s. 1s, there are 2 electrons. This is how you are going to represent electrons. Full arrow upside. One is up, the other one is down, upside down. Second one, I am drawing for 2s. This is for 2s. Once again, 2s has 2 electrons. Here I am representing 2p. When it comes to 2p, I told you electrons are bonding. Electrons are representing here as a pair. See? This is 1s, this is 2s, this is 2px, this is 2py, this is 2pz. In your note, you have received everything clearly. Read very well. If you have further clarifications, we can discuss. And when it comes to 3s, this is how it fills. I'll take another example for your convenience. See? Right, let's talk about what? We'll take oxygen, we'll take carbon, hydrogen, helium, lithium, beryllium, boron, carbon, 6. So, let's write 1s2, 2s2, 2p, 2p what? 2, 2, 4, 2p, 2. Right? So let's draw this. 1s, there are 2 paired electrons. In 2s, there are 2 paired electrons. When it comes to p, dumbbell shaped p orbital has, yes. Here, this is an important place U. Why? Filling of electron won't fill pairly. It fills one by one and finally it starts to fill pairly. See whether you can understand. 2 first shell, second shell, third shell no more. If it has filled, once again it starts from the beginning. Right? Okay. Read your note well and go through with the video again and again. Right? I hope you can understand this very well. Right? Because you all are clever students. Right? I'll come to see you with in another video. Until then, stay safe and I wish you good luck to you all. Goodbye. God bless you.